Chapter 1, Electric Charges and Fields, 12th Physics. Let us see the important questions of 1 marks, 2 marks, 3 marks, 4 marks for board exam. Here is the question first. The force applied on a charge Q when placed in electric field of the intensity E is. We know that E equal to F upon Q. Hence, if we find force, then force equal to QE. So the answer C is correct. Next, the electric field at a distance from R from a point charge is proportional to. The electric field due to point charge is written as 1 upon 4 pi epsilon naught Q upon R square. The relation of electric field with distance is 1 upon R square. So the correct option is B. Next, the electric field at a distance r from the center of an electric dipole. The electric field due to dipole can be written as equal to 1 upon 4 pi epsilon naught P upon R cube. P for equatorial position and 2P for axial position. So the relation between electric field and distance is R cube, 1 upon R cube. So answer number A is correct. The electric field at a distance R from a charged wire is proportional to. For a linear charge, the electric field intensity is written as 1 upon lambda equal to lambda upon 2 pi epsilon naught r, and the relation of electric field with r is 1 upon r. So C is correct. Next point is the electric field inside a charged hollow sphere is. The electric field inside a charged conductor or hollow sphere is always 0. So it is 0. Question number 6. An electric dipole is placed inside a hollow sphere. The electric flux associated with it will be. We know that the net charge on a dipole is 0. So the electric flux is also 0. So option number C is correct. The value of or elementary fundamental charge or elementary charge or charge on electron or charge on proton. This is 1.6 into 10 to power minus 19 coulomb. Next question is the SI unit of electric field is Newton per coulomb. We know that the formula of electric field is equal to F upon Q naught. The unit of force is Newton and unit of coulomb is charge is coulomb. So the unit of electric field is Newton per coulomb. Next one is question number 13. The angle between the electric field line and the conductor is. We note that electric field line is perpendicular to the conductor, hence the angle is 90 degree. The total electric flux emanating from a unit positive charge in the air is. From the Gauss's theorem, we know that phi equal to q upon epsilon naught. If charge is unit, then q should be 1 upon epsilon naught, and it is written as epsilon naught minus 1. So the answer A is correct. Here I am leaving some questions which are not important. If you want to learn each question, then you can download my LK Physics app from the Google Play Store, or you can subscribe the channel LK Physics from YouTube. Now see the question number 18. In an electric field E, the surface S is kept parallel. The electric flux bound by it will be. We know that the formula for electric flux is equal to phi equal to E S cos theta. You can write S or A for area or surface. Here surface is parallel, so the angle is written as 90 degree. For the surface, angle is written opposite. You know that for the parallel surface, the angle will be 0, but the angle is taken for the area vector which is perpendicular to the surface. Thus, here we take an angle of 90 degree. Cos 90 degree is 0, so the electric flux is also 0. Next question, question number 20. A hollow sphere is given a charge of 10 microcoulomb. Its radius is 2 meter. The intensity of electric field at its center will be. We know that the electric field inside a conductor is 0. So answer is 0. Now the question is, the distance between 2 point charges is r and force is F. If their distance is doubled, then the force will be. Now you can solve it. The formula for force acting between the charge is 1 upon 4 pi epsilon naught q1 q2 upon r square. For the next condition, f dash equal to 1 upon 4 pi epsilon naught q1 q2, the distance is doubled, so it is written as 2r whole square. If we solve it, then we get f dash equal to 1 upon 4 pi epsilon naught q1 q2 upon r square, and if we square 2, then we get 1 upon 4. Hence, the force will be F upon 4 times. Now question number 24. An electric dipole placed in unequal electric field lines, then which act on it? For unequal electric field lines, that is non-uniform electric field, there will be force and torque both acting on the dipole. So answer is both. For unequal electric field lines, that is non-uniform electric field. In non-uniform electric field, force and torque both are acting on the dipole, whereas in uniform electric field, only torque acts on the dipole. Now the next question is, electric field lines exist in the space in three-dimensional. It means they can spread in all the directions. Now the questions in the format of fill in the blanks. The question is, the property by which charges are differentiated is called polarity. Next is, an atom is electrically neutral. Now the next question is, the magnitude of the charge present in an electron is called elementary charge. I am leaving some questions which are not important for the board exam of this year. If you want to see all the questions, you can download LK Physics app and you can get notes, question bank, and videos of topic wise concepts. Now, next question is, the total charge of an isolator system is always conserved. Charge is scalar quantity. Now, the SI unit of charge is coulomb. Question number 13. The permittivity of free space or vacuum is, you learn this value. This is epsilon naught 8.854 into 10 raised to power minus 12 coulomb square per Newton meter square. The dielectric constant of air is 1. The dielectric constant of metal is infinity. And the sharing of charges with the earth is called earthing or grounding. Next one is, the intensity of electric field is a vector quantity. Now the question, the electric field inside a charged conductor is always 0. Electric field lines never intersect each other. The electric field lines are normal or perpendicular to the surface of conductor. Now this is also important. Electric field lines do not form closed loops, or electric field lines forms open loops, open curve. Do not hoga, then you can write closed. If do not is not, it is positive sentence, then open curve. Next is the net charge of an electric dipole is 0. In an electric field lines can be drawn. Infinite electric field lines can be drawn. Now the question for match the columns. Here is Coulomb's law, that is E 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Electric field, the formula is F upon Q naught. Electric dipole moment, electric dipole moment is Q into 2L. Here is electric flux, that is EDS cos theta. Torque on electric dipole, it is PE sin theta. For better preparation, you can note these questions in your notebook and practice it. Now the next match the column is Gauss's theorem. This is Q upon epsilon naught. Electric field inside the conductor is always 0. Electric field due to charged wire, it is lambda upon 2 pi epsilon naught r. Electric field due to charge sheet is sigma upon epsilon naught. Quantization of charge, it is Ne. Now the questions are in one sentence. Why is an atom is electrically neutral? Because the number of electrons and protons in an atom are equal. How will we find the direction of electric field from the electric field lines? The tangent drawn at any point on the electric field line shows the direction of the electric field at that point. If there is an electric field line, then it is a point. Draw a tangent at that point. This tangent will give the direction of electric field or magnetic field, anything. If it is magnetic field lines, then it will give the direction of magnetic field intensity. If it is electric field lines, then it will give the direction of electric field intensity. Next is, why do electric force lines form an open curve? Because they start from a positive charge and end at negative charge. Electric field lines are started from positive charge and end at negative charge. So they move from positive to negative. Does not move from negative to positive. So they makes open curve. Now the question is, if the distance between 2 point charges is halved, what will be the effect on the force between them? We know that the force acting between the charge is F equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Here R is halved, so it can be written as R upon 2. If we solve it, then we get F equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, and this 2 will go to the numerator, then it becomes 4. Hence, force will increase 4 times. Next format of question is in the form of true and false. And let us see the important true and false. When charge is transferred to a conductor, it immediately spreads over its entire surface. It is true. Now next question is, Coulomb's force is established up to the subatomic level, that is R is approximately equal to 10 raised to power minus 10 meter. It is also true. Next is dipole moment is a scalar quantity. It is false because dipole moment is a vector quantity. Now see the questions of 2 marks which are important for the board exam. The question is, what is meant by electric field intensity? Write its unit. What kind of quantity is it? Let us see the answer. Electric field intensity. The force experienced by unit positive charge at any point in electric field is called the electric field intensity at that point. The formula of electric field intensity is given as E equal to F upon Q naught. Thus, the SI unit of electric field intensity is Newton per Coulomb. It is derived from the formula that is SI unit for force is Newton and SI unit for Coulomb charge is Coulomb. Electric field intensity is a vector quantity. Now, this is also an important question. Two electric force lines or field lines do not intersect each other. Why? Two electric force lines do not intersect each other because two tangents can be drawn from the point of intersection, which will give two directions to the electric field, which is not possible. Consider there are two electric field lines, this and this. This is an intersection point, and you can draw tangent in this line and tangent in this line. There are two tangents from a single point which will give two direction of magnetic field intensity, which is not possible. So they never intersect each other. Now the next question is, what is meant by electric dipole? A system of opposite charges of equal magnitude situated at a small distance is called electric dipole. These are the charges and they have same magnitude but opposite directions or opposite charges. They are separated by a small distance. This system is known as electric dipole. Now this is the question, what is meant by electric dipole moment? Write its unit, dimensional formula and direction. Electric dipole moment, the product of the magnitude of any one charge of electric dipole and the distance between them is called electric dipole moment. You can also write these words from the formula. This is the formula of electric dipole moment. This is product of magnitude of a charge and distance between them. Its SI unit is Coulomb meter, that is unit of charge is Coulomb and unit of distance 2L is meter. Its dimensional formula is LTA. The dimensional formula for charge is AT and for distance is L. You can write ATL or LTA for dimensional formula. Its direction is from negative to positive charge. Next question is, write the limitations of Coulomb's law. It is true only for the point charges. It is true only for the stationary charges. These are the two limitations for Coulomb's law. Now, see the questions of 3 marks which are important for the board exams. Now, the important question is, write Coulomb's law and define unit charge. Write its limitations. Coulomb's law, the measure of electrostatic force between 2 point charges is directly proportional to the product of magnitude of two charges and inversely proportional to the square of the distance between them, and it acts along the line joining to the charges. This is the statement, and this statement can be written from the formula also. This is the electrostatic force acting between the two charges, and it is equal to the product of magnitude of those charges, and it is inversely proportional to the square of distance between them. Let us see the wording for this equation. If the vacuum between if the vacuum between 2 point charges q and q2 is situated at distance r, in the vacuum you can write in the vacuum 2 point charges q1 and q2 is situated at distance r, then the electrostatic force acting between them, according to statement, it can be written as F is directly proportional q1 q2 upon r square. In the sign of proportionality, we take a constant k. Then the formula is F equal to k q1 q2 upon r square, where k is equal to 1 upon 4 pi epsilon naught 9 into 10 raised to power 9, and it is a constant value. So the formula can be written as F equal to 1 upon 4 pi epsilon naught q1 q2 upon r square, that is 9 into 10 raised to power 9 q1 q2 upon r square. Now this is question number 9. It is also important. What is called an electric field line? Write its properties. Electric field line, an imaginary curve drawn in the electric field in which tangent at any point represents the direction of electric field. The properties of electric force lines or field lines are: they start from positive charge and end at negative charge. If the charge is single, then they start from infinity or end at infinity. They are continuous curves in charge-free region. They never intersect each other. They do not form a closed loop. They represent strong electric field when they are dense and weak electric field when they are rare. They are normal to or perpendicular to the surface of conductor. The tangent drawn at any point in the electric field lines gives the direction of electric field intensity at that point. These are some properties. If this question is asked 2 marks, then you can write two properties. If it is asked in 3 marks, then you can write three properties or more. Now see the questions which are important for 4 marks. The question is, state and prove Gauss's theorem in electrostatics. The statement of Gauss theorem is the total electric flux passing through a closed surface is 1 upon epsilon naught times to the total charge present inside it, where epsilon naught is permittivity of vacuum or free space. The formula is phi E equal to Q upon epsilon naught. This is the statement, and now see the deduction of Gauss's theorem. First of all, you draw a sphere with center O, and here is charge plus Q. Now draw a Gaussian spherical Gaussian surface of radius r. There is a small area element in which P point is lies. The direction of electric field is along the radius, and direction of area vector is ds. They are in same direction. Now write wordings for the diagram. Suppose charge plus q, this is plus q, is located at point O in vacuum. Imagine a spherical Gaussian surface of radius, this is Gaussian surface of radius r, around it, whose small surface ds has point P. This is a small surface and there is point P on which the direction of electric field intensity will be radially outward. The direction of electric field is radially outward. This is along the radius. Electric field intensity at point P. Now the electric field intensity at point P is equal to 1 upon 4 pi epsilon naught q upon r square, and the direction of electric field intensity is along OP. It is radially outward. You can see here from the figure, the direction of electric field is from O to P. Now we find electric flux d phi e, electric flux passing through a small surface. The formula is EDS cos theta, but theta is 0 for this condition because the area vector and electric field are in same direction. So we take angle between electric field and area vector is 0. Now d phi equal to EDS because cos value of cos 0 is 1. Then we find total electric flux or electric flux through the entire surface. Then we integrate. This can be written as phi. This is E, and this is the sign of integration of small area element ds. Now putting the value of E here, this is E. The value of E is in first equation, that is E equal to 1 upon 4 pi epsilon naught q upon r square. You have to put the value of E at this place, and this can be copied here. Now the integration of ds is equal to the surface area of sphere. The surface area of sphere is 4 pi square. You can cancel out from the equation 4 to 4 pi and r square I square, and we get phi equal to q upon epsilon naught. Hence Gauss theorem is proved. Now the next question, establish an expression for electric field intensity due to uniformly charged thin spherical cell when the point is outside the spherical cell, when the point is on the surface of spherical cell, when the point is inside the spherical cell. There are three conditions for which we find electric field intensity of a uniformly charged spherical cell. Now, for the first condition, when point is outside the cell, this is the diagram. This is charged cell whose center is O and radius is R, and the point outside located is P. Draw a spherical Gaussian surface with center O and radius R. There is a small area element in which P is point. The area vector of this small area element is ds, and electric field also is along the same direction of area vector. Now write some words about the diagram. Suppose center of the charged spherical cell is O and the radius is R. Then there is point P at a distance R from its center. This is point P at a distance R from its center. Which intensity of electric field is to be found? Its direction will be radially outwards. The direction of electric field is radially outward. Taking R as a radius and O is center, we construct a spherical Gaussian surface. Now we find electric flux passing through the small surface. The formula for the electric flux is d phi equal to EDS cos theta. Here theta is 0 because electric field and the area vector, this is area vector, this is electric field, are in same direction. So the value of cos 0 is 1. We get EDS. Now we find total electric flux passing through the entire surface. For total electric flux, we integrate the equation. Then we get phi E, this is E, and the integration of ds. The integration of ds is equal to 4 pi r square, which is equal to the surface area of the sphere. This is phi equal to E into 4 pi r square. But by the Gauss theorem, We have phi equal to q upon epsilon naught. From equation first, this is equation first, this is equation first. We put the value of phi e. This is the value of phi e equal to 4 pi r square q upon epsilon naught. By transposing 4 pi r square, we have equal to 4 pi epsilon naught q upon r square. Thus, it is clear that the spherical shell behaves as if the entire charge is contained at its center. The next point, when point lies on the surface of the shell, then small r equal to capital R. Let us see the diagram. If this point lies at this point, then small r equal to capital R. So we put here in the place of small r is capital R, then we have equal to 1 upon 4 pi epsilon naught q upon r square. This is the electric field at the surface of sphere. Now, when point P is inside the cell, that is small r is less than capital R, the electric field is 0. Since all the charges of a spherical shell are on its surface, the intensity of electric field inside the cell is 0. So there is no charge inside the cell, so electric field is 0 inside the cell. Now see some important numericals from this chapter from the NCERT book. Two small spheres placed at a distance of 30 centimeter from each other in air have charges 2 into 10 raised to power minus 7 coulomb and 3 into 10 raised to power minus 7 coulomb respectively. Find the value of force between them. So we have solution that there is R equal to 30 centimeter. Centimeter is converted into meter. So in place of centimeter, we have to put 10 raised to power minus 2. Now 330 can be written as 3 into 10. So this will become 3 into 10 raised to power minus 1. Minus 2 becomes minus 1 meter. Now the value of magnitude of first charge is 2 raised 2 into 10 raised to power minus 7 coulomb, and value of magnitude of second charge is 3 into 10 raised to power minus 7 coulomb. We know the formula for force F equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square from the Coulomb's law. By putting these values, the value of 1 upon 4 pi epsilon naught is 9 into 10 raised to power 9. The value of Q1 is given from the question 2 raised to power minus 7, 2 into raised to power minus 7, and the value of Q2 is 3 into 10 raised to power minus 7, and the value of R is, this is the value of R, 3 into 10 raised to power minus 1, and this is a square, so we have squaring 3 into 10 raised to power minus 1. Now, first of all, put the numbers aside and powers at other side. There is number 9, 2, 3. So there is 9, 2, 3. Here, this is a square, so we take 3 into 3. Now see the powers, 10 raised to power 9, then minus 7, then minus 7, and it becomes minus 2. At the numerator, it becomes plus 2. So 9 minus 7 plus 2. Cancel out 3. Again 3 3 ja 9, 3 2 ja 6. This is 6, and the power will be 10 raised to power minus 3. Hence the force acting between these charges is 6 into 10 raised to power minus 3 Newton. Now see the another important question. An electric dipole of dipole moment 4 raised to power 4 into 10 raised to power minus 9 coulomb meter aligned at 30 degree from the direction of uniform electric field of 5 into 10 raised to power 4 Newton per coulomb. Find the value of the torque acting on the dipole. It is known that the value of P, this is dipole moment, is 4 into 10 raised to power minus 9. Then electric field is 5 into 10 raised to power 4. This is electric field, Newton per Coulomb. And the angle of alignment is theta equal to 30 degree. We have to find torque in uniform electric field on the dipole. So the formula of torque is tau equal to Pe sine theta. By putting the value of Pe and sine theta, we have the value of P is 4 into 10 raised to power minus 9. This is, and value of E is 5 into 10 raised to power 4. This is, and sine, this is sine, and angle is 30 degree. So there is sine 30 degree. Now we had copied the above numbers. Here sine value of sine 30 is 1 upon 2. Now cancel out 2 4 ja 2, 2 5 ja 10, this is 10, minus 9 and 4 becomes 10 raised to power minus 5. Then it becomes tau equal to 10 raised to power minus 4 Newton meter. So these are the important questions from first chapter. You have to write it and practice it. If you want to question bank and notes, then you can download LK Physics app from the Play Store.